Hi everyone, welcome back to Geeks for Geeks. In this video, we'll be discussing the problem count all possible paths. Basically, in this problem, the problem says that you are presented with undirected connected graph. So we'll be given an undirected connected graph here consisting of n vertices. So there will be n vertices in this graph and connections between the nodes or the elements will be indicated by a adjacency matrix. So we'll be given an adjacency matrix which will tell us which node is connected to each other and which node is not. Okay, so your objective is to determine whether it is possible to start from any node X and return to it after traversing all the vertices exactly once. Okay, so if this is possible, then you have to do what? Then you have to return 1, otherwise you have to return 0. Basically, the last two lines are the main thing. Your objective is to determine whether it is possible to start traversing from a node. So if it is possible that we start traversing from a particular node, let's say X, and we return back to that node X after traversing all the vertices at least once and using each edge exactly once. So basically this comes under the category of Euclidean path, right? Now what is a Euclidean path? So basically in this case you will have to use a theory that is Eulerian path, right? Now what happens in Eulerian path, or you can say circuit, right? So in this case we say that a path is a Eulerian path if and only if the condition is satisfied that we visit every edge exactly once. Okay, a path is said to be a Eulerian path if we visit every edge exactly once. Okay, then it is known as a Eulerian path, and also at the same time, like the starting vertices and the ending vertices are same. Now when can we say this? So basically suppose that if I have a graph, let's say a graph is like this. Let's say we have a graph which is something like this. Okay, so if I have made a graph which is like this, right? So in this particular graph, does this graph satisfy? Because if you will see, let's say this is node 1, 0, let's say this is 2, this is what, 3, and this is 4. So you can see like in this graph, it has a Eulerian path. For example, if I start from where? If I start from 4, okay, then from 4 I can go to 3, then 0, okay, then I can go where? Then I can go to 1, and then 2, and then 0. So basically you can see in this case what is happening here is basically if I started, right? So let me just write it once again. So if I would write it, so let's say if I start from 4, then 3, then I go to 1, then I go to 2, then I go to 0. So you can see that I have traversed everything exactly once, and there is no Eulerian cycle because there are two nodes with odd degree, right? If you see, so 0 has odd degree, right, and then another node which has odd degree is 4. So there are two nodes with odd degree. Whereas if you will see another example, let's say if we take this particular example, right? So if we take an example like this one, okay, now in this particular example, let me start traversing it. So suppose that if I start traversing from let's say if I number it as 1, 0, then 3, then 4, okay, then 2. If I start traversing it, so if I start traversing, let's say from 2, and then from 2 I go to 1, then I go to 0, okay, then from 0 I go to 3, then I go to 4, then I go to from 4 I go to 0, and from 0 I go to 2. So you can see that I started from the same node and I ended at the same node, right, without traversing any edge more than once. So we traversed each edge exactly once here, right? That is the main thing. So you can see that this satisfies the condition, right? And this graph has Eulerian cycle. Now what is the unique thing here? The unique thing is that if you will see the degree of each node, so the degree for the node 2 is what? even, because 2 is connected to 2 people. 1 is also having the degree as even. 0 is also having degree as even because 0 is connected to 4 people. 3 is also having degree as even. 4 is also having degree as even. So each node should have even degree. Okay, if every node has even degree, then in that case we will say that yes, it is possible. Otherwise we have to say that no, it is not possible. So for determining this, what we need to do is we need to iterate through the adjacency matrix of all the nodes, and if every node has got even degree, then at the end of the day we have to return true. Otherwise, if there is any node which has odd degree, then it is not possible. For example, you could see for the first test case it was not possible, because in that case what we were doing was we were basically having a node with odd degree, right? So if we were having a node with odd degree, then it is not possible. If all the nodes are there which are having even degree, then this part is possible. So let us try and code this up and see how the implementation will be done. Okay, so in this case what we'll be doing is we will start coding this up. So we'll iterate through the adjacency matrix that has been given to us. Okay, so let's do it right here. Okay, so what we will do here is we'll say that for int I starts from 0, I is less than paths dot size, right? Then we'll do an I plus plus. Now after that, what we will do here is we'll say that for int j starts from 0. Before that, obviously I need a counter because I need to count the degree of the current node that I am at. Okay, and then I'll say that j is less than paths dot size. Then what I will do is I'll do a j plus plus. After that, what I will do is if it happens that the paths of ij is equal to 1. So this means what? That if from I can reach j, if I and j are connected, so this means that you need to increase the degree for ith node. Okay, so you need to do a count plus plus. So basically for every node you will you will count the degree after the j loop will be over. So for every node you will understand that what is the degree of that node or how many nodes it is connected to. And if there is any node for which the degree for which the degree is odd, so if the count modulo 2 equal to 1, then I need to say it is not possible and I have to return 0. Otherwise, at the end of the day, what we'll do is we'll return 1. That is, we need to return true that it is possible to do so. Okay, let us try and compile this code to check if it is working on the samples or not. So you can see our code is working on the samples. Let's try and submit it. So you can clearly see that our code was able to pass all the test cases. Thank you for watching this video and keep coding, guys.